Hello guys, in the last lecture we have studied the entire concepts of outliers where we studied about what is an outlier, what are the problems that comes when we use the outlier. So how you can able to identify the outlier based upon the image and all we saw in the last lecture. So we will going to implement all of the concepts that we have done in the last lecture, that is IQR, Z-score method, everything that we'll going to implement in this lecture. So for doing this, what we'll going to use, we have to use one library called as Matplotlib. Okay, so Matplotlib. So in this particular coding we won't be implementing Z-score because Z-score we anyways have to implement when I teach you normal distribution and probability. So only in this lecture we'll going to implement IQR. Okay. So now to we'll going to use Matplotlib, and if you want we can also use Pandas also. It depends upon our choice. So for this what we have to do, what are the objectives today? First we have to identify the outliers from graph point of view, means a pictorial visualization point of view. So this is the first objective of this particular lecture. Second thing is understanding the concept of Boxplot in coding point of view, and then we have to solve the IQR method to remove the outliers. Okay, so these are the three things that we will going to see in this lecture. So for this what we have to do, we have to use we have to first import the libraries. So here you go to terminal. If you click on the new terminal, you will get the terminal like this. If I click on the present working directory pwd, this is the path that we are going to use. So in this here I created one particular folder, so I'll be writing this this particular folder I will going to write. And now what I will do here, I will first install the modules. So what are the modules that we are using? Matplotlib, and what we are using, Pandas we are using. So if you click on this, already these particular modules have been installed successfully. So we will just import the module. So import pandas as pd and import matplotlib as .pyplot as plt. So now it should be mat, it's not map, it should be matplotlib. Now what is our concept to understand outliers from visualization point of view. So outliers from visualization point of view. So for this what I will do, I'll create a folder called as I'll create a data called as x. In this x what I will write, I will pass this value 60, 61, 62, 63, 64, 65 I will going to pass here. So in this 60 to 60, 60, 61, 60 to 65, and I will going to pass 99 here. So what is the first method that we studied? We studied about the concept of histogram. Okay, we studied about the concept of histogram. So now here in this what I will do, here we have to plot this particular thing. So here I will write plt.histogram. Histplot we will going to see, and histplot what you have to specify, you have to first specify the data, and here you have to pass the bins. So here in bins, what are the bins that I will going to pass? I will pass 5 bins. What are the 5 different bins I will going to pass? I will pass 10, 20, then I will pass 50, 70 and 90, 100 I'll going to pass. So these are the bins that I passed. So what are the meaning of this particular bins? If I say 10 means, the values from 0 to 10, values from 0 to 10 is nothing but 10. 20 means 10 to 20. 20 where 10 is included, 20 is excluded, 20 to 50, then 50 to 70, like this you will going to represent. So here we plotted this particular thing. Here we will going to write plt.title, here we will going to write histogram outliers we will going to write, and then what we will do, we will just write plt.show function. And now what we will do, we will implement this code. So python outlier.py. If I implement this particular code, here you see that here the majority of data is present here between 50 to 70. Majority of data is present between 50 to 70, and here you see that in this particular data, this is an extreme point, this is an extreme point, only repeated once, but this point is repeated 6 times. So that's why you can say that this particular thing is an outlier, as it is going towards the left skewed, and here this is an outlier because it is going towards the right skewed. So that's why these particular points are the outliers. So this is how you can able to represent the outliers in the form of histogram. So now what we will going to do, we will also implement it in the form of box plots. Here I'll write box plot, and in this box plot I will use the same kind of data. For now I commented out this data because here we have to show for the this also box plot. So here I'll write blt dot box plot. Here I'll pass the value as x. If I want to specify the title, here I'll write box plot. And one very important thing I want to show. Now if I didn't wrote the value as plt dot show, so I will try to execute this file, it won't work. You see, it won't work. Why it is not working? Because we didn't wrote the value as plt dot show function. So we have to always specify the value as plt dot show function. And if you see this particular plot, here you see this particular circle is there, this particular circle is there. So what are these circles? This circle represents the outlier, and this is the original box plot, how it looks like. And so this is how you can able to see. If you want, you can either zoom in, zoom out. This all you can able to do from the plot here itself. If I go here little big, you can able to see the plot in more detailed manner. So like this you can able to understand how you can able to show the box plot in the case of scatter plot. Now the next topic comes is how you can implement it via using this one. What is this one? Using scatter plot. So for scatter plot, what I will do, I will take one separate data as age, and in the age what I will pass, I will pass 18, 19, 20, 21, 22. I'll going to pass as the age value, and here I'll pass the 18, and here I'll pass the value as salary. In salary what I will pass, I'll pass as 10,000, 20,000, 30,000, 40,000, 50,000, and I again pass the 50,000 as the value. Now what I will do here, there is one function called as plt dot scatter. So in this scatter what I will do here, you have to pass the two data that you have to pass, that is x, that is the x-axis, y-axis you have to pass. So in x-axis we want to keep as age, in salary I want to keep the value as this one, salary as the y-axis. If you want, you can specify the color also, you can specify. So for now I'll going to specify the color as red, I'll going to specify. So now again you have to always write the plt dot show function, and here I will specify the title also, that is the scatter plot. Now what I will say, I will going to comment out this, and I'll just implement this code. If I click on this, you see here this particular red color is showing the outlier. So now here if I want to draw the line, let's say if I want to draw the line for this particular thing, line for this, so instead of scatter I will going to write the value, here I will going to write the value as plot. To draw the line, use plot function. To mark the points, use this scatter function. So here I will write the value as a color as red, and here what I will do, here I will write the value as markers. So what are these markers? Markers represent the what are the labels, like if a particular point is there, how you can able to represent the marker. For that you can use the marker. If you don't want to use, no issues, you can directly write here like this and just click on this particular outlier dot y. So here there is one error here, that here this RGBA, this color you cannot specify here. So just I'll write age and salary, and here I will going to just click on this, enter here. Now you see that here the particular plot is coming, and here you see that particular plot is going towards left side. So here you observe that this particular point is going towards the left hand side, means this from here instead of after going to straight line, it is again going to left side, means there is an outlier present here. So that's why to identify via plot you can do like this, but it's not correct to use plot. Instead we will going to use this scatter itself. Okay, to draw the line between the points you can specify the scatter plot, and if I click on again execute, you see that this particular points, and here you can identify that this particular point is an outlier. So this is how you can able to identify the outliers from visualization point of view. from box point of view and from scatter point of view. Now we will going to study how you can remove the outliers. If the data has outliers, how you can remove this, that we will going to study now. So now our objective is we understood how the outliers look like in the visualization point of view. Now we have to remove the outliers. So to remove the outliers, what are the methods that we have? We are having the IQR and we are having the Z-score. But for now we are not going to use this Z-score method, as in normal distribution. When I'm going to teach in the inferential statistics, there we will be anyways have to use the Z-score approach. So that's why I'm not going to teach the Z-score method now. So now what I will going to use here see, when we use the IQR approach, you know, you have to use the concept of quantile. So let's say I selected this particular data as X. Here what I will do, here I will write plt dot here I will write plt dot box. I will write here I will write Boxplot. Let's see if I specify, and if I write X here, and if I execute this particular command here, and sorry, here I have to write the plt dot show function, then only it will work. Always it will work like this. So here you see these particular 2 points are there. Now we have to remove these 2 points. So how will we remove using the Python? Very simple approach. Now one very important thing that you have to remember here is, here what I will do, here first I will use this subplot concept. 1, 2, 1 means I want 2 subplots. In that first subplot is the below plot that we want to plot. So here what I will write, here I will specify before removing outliers. Now what I have to do, first I will calculate the final values, and then I will going to merge it in the subplot itself. So now to remove the outliers, what we have to do, very simple this is. So you have to specify the value of quantile. So what is the quantile? Here one very important thing here, there are 2 approaches you can use to remove the quantiles. Either you can convert it into pandas, or either you can convert it into NumPy. So now what we will do, we'll convert this X into the data frame format, that is the pandas format. So finally here what I will write, here I will write the value as data. Here I will write pd dot data frame. Here what I will write, here I will pass the value as the X here. Okay, X here I will going to pass here. So now here what I will write, here I will also specify the column. So what is the column that I want to give? I want to give this value as, let's say, marks. Okay. So now what I will do, I will just want to first print the value of the data to check whether everything is working fine or not. So here I will click on this particular outlier.py. Here you see, here there is one error that like this you cannot able to specify the column. So what I will do, I will go to the official website, or I'll go to GPT, any mode I can use, and here I have, so here just I will write what is the error. Here I will write. So here it is telling that here column marks you cannot write it. The case sensitive plays a very important role here, and that too you have to pass it in list format. So that's why what I will do, I will going to copy this, and here I will going to write, I will going to pass like this. And now if I execute this particular outlier.py, you see that here the marks column has been formed and it is showing like this. So it has successfully converted into the data format. So now what I will do here, if I want to create a box plot, I'll directly create it for data instead of creating for X. I'll directly create it for data itself. So now what I will do here, I have to remove the quantiles. So to remove the quantiles, there in pandas there is one function called as quantile function. So here I'll write the value as data, and in this quantile. So what is the quantile value that I have to pass? Here I have to pass the 25%. So to pass it 25%, it is telling you have to pass it in float value. Means 25% how you can write? Here you can write as 0.25. Okay. Here Q3 what will pass? Data dot quantile. Here I'll pass 0.75 going to pass. So now based upon this, what you will do, you will calculate the value of IQR. So IQR is what? Q3 minus Q1. Q1 will going to pass. Now the upper and lower viscous, or upper and the lower bound, if you want to write the logic for it, so you know, right, lower means what? Q1 minus 1.5 into IQR, correct? Similarly, upper means what? Q3 plus 1.5 into IQR. This is the logic I explained in the last lecture. So now what happens here? If you want to check the values, you can directly print and check the values. Yeah, so you understood what are Q1, Q3, IQR lower. If you want to check all of these values, you can directly go to print and write Q1, Q1, Q3, lower and upper. If you write all of these values and if I click on this execute option here, outlier.py, here you will get all of these values like this 0.7, like what are the like what is the 25th value, what is the 50th value, all you will going to get these values. So what are the 69.5? So with float values it will going to give the values. Okay, so these are the values that it is coming, like 25th value is this one, then 75th value is this one. So like this it is coming like this. Now after printing, now what I will do, I'll again go back to, I will remove this thing, and now you have to specify the condition. What is the condition for removal of outliers? The condition is very simple. If the value that comes, like if the df of this particular, if the data which is having, if the data of marks, if any of the data of marks is greater than the upper value, consider it as an outlier, or if the value is less than the lower, then consider it as an outlier. Always use or here, don't use and, because and will confuse the logic. Okay, so here what is the condition? Condition to remove or filter outlier. Filter outlier. For filtering, what we will do, we are going to use the condition. So what is the condition? That you have the data. Inside data, what you will write here, we will going to write the value as if the data of marks that we are having, this marks, let's say we are having, if this marks value is greater than the upper value, not equal, just upper value greater than, or you want to if the values of greater is less than the upper value, or if the values of marks is greater than the lower value. If any of this condition matches, then that data is been filtered properly. So now the problem with using AND here is, if the particular value is less than the upper, let's say we are using if I use the AND condition here, the problem with using you cannot use here, or you have to use the AND condition. Why I have to use the AND condition here? Because if the value is let's say you are taking the value as -3, if -3 you know it is less than the upper range, so it will print the value, or means any one value it should able to print. So but here this is not satisfying the lower condition, right? So that's why you have to always specify the AND. Sorry for telling you, you have to always specify the AND value. So df AND, if this value is like this, just you have to specify the value, you have to write this condition. And now if I write the value of filter here, you will see the correct answer. If I write print like this, now here it is telling one very big error is there. So what is the error it is getting? Very simple. You go to this, you copy this particular data, now here go to the GPT and ask what is the error. Because our logic is correct only one or two small mighty mistakes are there. Either you can debug the errors, or we can directly able to use this. It is not a problem for us. So so like this you can able to do like this. Just copy this thing. Everything is in our code is correct only. Just this particular condition is not correct for us. So and parenthesis is very important. Always check for the parenthesis marks. And once if I execute this command here, now you see that here if I see the marks, only 60, 61, 62, 63, 64, 65 are there. Means this 99 and 10 are been removed. Now if you want to see via the plot here, so what I'll do here, I will just keep this subplot. I'll copy this code and instead of data I will pass the value as filtered, and here I'll write removing outliers, after removing outliers. And now if I click on this command here, this is the before removing outliers and this is the after removing outliers. One very important thing I want to tell you here. Now let's say if I execute this particular command here, you see that here both the figures are coming in differently. Why it is coming differently? Because both of them have written separately. They have not written in one single thing. And we also use the plt.show twice. We should not use the plt.show twice. So here I will comment out this, and I'll copy this out, then I'll comment out this data, and then here I will write this data. Now the power of plt.show I will tell you. If I execute this command, it will still show separately, because we want that we first enter this particular plot and we want to show it out, and then we enter this particular plot, then we show it out. That's why in both images it came. Now but if I remove this plt.show from first, and now if I pass this plt.outlier.py, you see both of the images have came successfully. So this is the power of using the plt.show function. Every time don't use plt show function. Plt.show function, what it tells, it helps in displaying the particular image. Now you see here, before removing the outliers, what has there? These are the two circles that have came. After removing outliers, what it has happened? There is no circle here. Means the outliers have been successfully removed from the dataset. So, and after removing the outliers, you observed one thing. From here, if you see the bins that we selected, that is 10, 50, 70, 90, we selected the bins, right? After removing the outliers, it has automatically selected its own bins, and it has removed the 10 and unnecessary bins it has removed. So this is how your entire outlier detection, outlier removal has been take place. Now if I execute all of these commands, if I explain you all of these commands once, if I remove these things and if I execute all of the commands, then you will understand my things very clearly, what we have done till now. Okay, so here I will going to remove this command, because if I don't remove it, it will give me very big error. So that's why I will execute all of the commands here. So if I execute this command first, python outlier.py, you see first through the help of histogram you identified left side the data is outlier, right side the data is outlier. First image is done. Second image, identify the box plot using the outlier. See how the outliers look like. These circles plays a very important role in outlier detections. Then scatter plot. This particular point is an outlier. So after doing these three, what we have done, we have used the interquartile range method to remove the outliers. So before removing outlier, the image was looking like this. After removing the outliers, there is no circle here. Means the outliers have been successfully removed from the dataset. So what we have done, so this is how we have done. First we implemented histogram, then box plot, then scatter plot. We have identified the outlier. Then we use this particular data, and we use the interquartile range formulas to, and we have used the filter condition to filter out the particular data. If you want to print the outliers, to print the outliers, what you can use, you can just change the sign and you will get the outlier values. Like if I go here and if I write here plt.filtered, here instead of I'll keep the value as less than, here I'll keep the value as greater than. If you see this data here, instead of writing filtered, I will write as outliers. Here I will write the value as outliers. If I write these values here, and now if I execute this particular command here, now you see this is the histogram, this is the box plot, this is the scatter plot. Now you see here that after outliers, if you see only this particular data 60, 61, 62, 64, only these values are been printed. Means what, we have removed these are the outliers and we have successfully removed the outliers. So this is also one more approach to remove the outliers from the data. I hope you understood the concept of outlier removal in very detailed manner. So that's it guys for this lecture. In the next lecture we will going to discuss about covariance and correlation, very important topic for understanding these concepts, and then descriptive statistics will end. So that's it guys. Please do like, share and subscribe guys.